And we're back. I lied.
Okay, now, when you get down to question number 12, you got a copper bar with a volume of 0.05 cubic meter, it's mass of the copper bar, what does the copper bar weigh, okay? Now, you're going to have to look on your sheet to figure out the densities and go from there. So you're going to have to use that sheet extensively on this. Now, it says how much water was displaced by the copper bar. So, if you remember back, hopefully you did this lab at some point where you take a graduated cylinder, and let's say you're at 25.0 milliliters, and you drop a rock inside of here, and it's fully submerged, and it goes up to like 27 milliliters. So what was the volume of the rock? 2 milliliters. So this is a common misconception. The volume of the rock displaces an equal volume of the water. Okay? So if you've got a 2 milliliter rock when it's fully submerged, you will displace 2 milliliters. So if you don't know what the volume is, submerge it, see how much the water goes up. But that doesn't equate with weight. Okay? Now, so here's kind of a common question. So let's say that we take a beaker of water and we fill it up to the brim, and then we put ice cubes in it. Obviously some of that water is going to overflow. Okay? So visualize this. I've got a beaker completely full of water, like all the way up to the brim. But then I've also got some ice cubes in it. That on part of that ice cube is floating above the surface. Okay? So you got that visual. This is filled all the way up to the brim. Like you put one more drop of water in it, one drop of water is going to come out. So here's my question. As the ice floats, okay, right, just floating up here, you add one more drop, it's going to, but as the ice melts, what's going to happen to the level of water in the container? Three things can happen. It will continue to overflow because it's melting, and you're adding water to the system. Okay. Volume could go down because ice is less dense than water, and that's why it floats. Okay. So as it floats, as that melts, you have less dense ice that's going to turn into water, which is more dense, and then the volume is going to actually go down a little bit.
So part of the ice is sticking out.
Or it stays the exact same.
So part of the ice is sticking out.
Part of the ice is sticking up above.
Okay, then
Because
it's
it's
gonna go up.
floating. But it's filled completely up to the brim. Like you put in one drop of water comes out. It is completely filled all the way up to the top brim.
It's gonna.
So what's going to happen as the ice melts?
It's gonna overflow.
It will continue to overflow.
That one.
Will the volume go down?
No.
Or will the volume stay the exact same?
No, it's going to overflow.
Stay the same.
Overflow. Overflow.
Well, it depends on how much.
The ice is under the water.
Is it like very significantly over the poking out?
Yeah, I mean,
Because it's going to
you've seen like an ice cube float. You know, it's sort of like.
Yeah.
Okay, then yeah,
ice
it's
already
gonna-
in the water,
it's gonna
so
overflow.
Add more.
Yeah, but if it's more dense in the liquid form, then like it'll take up a lesser volume.
Yeah, but it's not gonna.
That's it.
Since it's
Stay the
depending on
same.
density, assuming ice is, say,
I'll just do it at
900
home.
kilograms per
Huh?
cubic meter,
I'm
only
just gonna
about
do it at my
10% of
house.
it will be
Find
sticking out the
out.
top.
The difference, but the difference between ice and water is not going to be big enough to.
Okay, let's look. Okay, stop. Okay. Let's just say that you start with a beaker completely full of water, filled to the brim, and you add some ice cubes to it, right?
Add.
Okay, just hold on. Okay, you're starting with completely full of water, and you add some ice cubes to it. Okay, you add some ice cubes to it. Is the water going to overflow?
Yeah.
Yes.
Why?
Because now there's too much for the beaker to hold.
Right?
They're displacing the water.
Okay, so it's going to displace some water, right? Now, here's the million-dollar question. As that happens, right, is there a buoyant force acting upward on the ice cube?
Yes.
Yes.
That's equal to what? Equal. What is any buoyant force equal?
Rolling weight.
The weight of the water that's displaced, right? So we've already displaced water that's equal to the weight of the ice cube, right? So as it melts, are we going to change the weight of the ice cube?
No, it's the same
No,
amount.
because if
Same
I
weight.
take an ice cube and it weighs 100 grams,
And you put it in
and I
water,
put it on a scale and let it melt, guess what?
It's gonna be 100 grams.
It's still going to be 100
It's a
grams.
different form.
So even as it melts, does the ice cube still weigh the same?
Yeah.
Yes, you're just changing it into water. So since we already displaced the weight of the fluid, the weight of the ice cube,
Dang, I'm wrong.
it's not going to overflow.
Oh, what the heck?
Okay? Because you already displaced the weight of the ice cube.
Which number is
Even
this?
though some of it's still poking out of the water?
Yeah.
Okay.
But it's still, you've still displaced the
Oh,
weight
the
of
weight,
the ice cube.
okay.
And when it melts, it's still the exact same weight. So you're not displacing the volume of the ice
Well,
cube.
it's the weight.
You're displacing the weight of the ice cube. Okay? That's the whole key to the question.
Right.
Okay? That's the whole key to the question.
Which
All
question
right.
is that?
So, now we're done. Now you're done. So ideally,
12?
you maybe crank through the rest of that lab, and then this buoyancy assignment looks much
That has
more
nothing to do
daunting
with
than it
ice,
is. It's actually pretty simple. So here's what we've got. We've got to get through some
That might be one of the
more
book
fluid
problems.
stuff with relating to pressures, okay? And then, so Thursday we'll review, and you'll have that final on Friday. So we got 2 more days, like a buoyancy lab tomorrow, and then that pressure stuff Wednesday, review on Thursday, test on Friday, review on Monday, final Tuesday.
Movies.
So how many more assignments?
So what are we doing Friday?
That last Friday,
Yeah.
we're bringing stuff, we're showing out.
Oh, okay. So just
We're
like
bringing
Africa Day.
Smash.
We're getting ready.
Huh?
So just like Africa Day kind
Yes.
What we getting ready.
Can we go through that
Frisbee, or-
slideshow again?
Yeah.
Because I was absent that day when you were.
Are we done?
when you finished
Yeah, we're
it.
done.
Bye-bye, everyone. Please like and subscribe again. I'll see you in the next one.
So, on the t-shirts, just remember $5 will go to.
This episode of SC on Snap is finito.